Okay, let's start with chapter 1. One of the things we talk about in math is mathematical reasoning. We want students to be able to reason out a problem, to think about it logically, and to take steps. Okay, that's one of the main reasons we learn it. We're going to talk about inductive and deductive reasoning in this section. The process of arriving at a general conclusion based on observations of specific examples is inductive reasoning. So let's go through that again. We're going to start with specific examples, and we are going to arrive at a general conclusion. So we start with examples, we arrive at a conclusion. That's called inductive reasoning. Now, what we end up with is a conjecture hypothesis. It's a conclusion that we formed using inductive reasoning, and it may or may not be true. And one way to prove it is not true is if we can come up with a counter example, something that makes it false. So one of the first examples they give you, example 1, we look at this and we say, okay, I have 2-digit numbers. Let's look at the answer. If I add these up, I end up with 120. I came up with a 3-digit number. Okay, if I add these up, I end up with 102. I came up with a 3-digit number. So my conjecture could be that every time we add two-digit numbers, we end up with a 3-digit number. Now that's just what I'm guessing. Then I'm going to see if I can prove that false. So let's look at this example. If I add 56 and 43, those are both 2-digit numbers, but I end up with 99, which is also a 2-digit number. So what I found is that my conjecture was false because I have a counterexample that proves that every time you add two-digit numbers, you do not necessarily come up with a 3-digit number. Let's look at the next one. Now this one is a strong inductive argument. Okay, so in a random sample of 380,000 freshmen at 772 four-year colleges, 25% said they frequently came to class without completing readings or assignments. We can conclude that there's a 95% probability that between 24.84% and 25.25% of all college freshmen frequently come to class unprepared. This technique is called random sampling. Okay, it's discussed later in chapter 12. Each member of the group has an equal chance of being chosen. So we can make predictions based on this random sample for the entire population. So this would be a strong inductive argument. But let's look at a weak one. Neither my dad nor my boyfriend ever cried in front of me. Therefore, men have difficulty expressing their feelings. Now, this conclusion is based on just 2 observations. That's it, just 2. Okay, so this sample, it's not random and it's not large. So we really can't use this to represent them all. This would be a weak inductive argument. Let's look at another example using inductive reasoning. So we're going to use it for number patterns. It says identify a pattern in each list of numbers, then use this pattern to find the next number. So we have 3, 12, 21, 30, 39. Now if it's not going up or down really fast, they're probably just adding or subtracting a number, which means adding a negative number. Okay, so let's look at it. This one's not going up terribly fast. Let's see if we can identify if they're adding the same number each time. 3 plus what would give you 12? That would be 9. And then 12 plus 9 would give you 21. 21 plus 9 would give you 30. 30 plus 9 would give you 39. So what they're actually doing is they're adding 9 each time. And we just need to do 39 plus 9 to get the answer of 48. Let's look at another one. This one has 3, 12, 48, 192, 768. Now we're going to use inductive reasoning. We're going to see specific examples and we're going to make a general conclusion. Okay? These are going up really fast. If they're going up really fast, you're probably multiplying by the same number. If they're going down really fast, you're dividing by the same number, which is the same as multiplying by a fraction. Okay? So in this one, I don't think they're adding the same thing. Let's look at it. 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. 192 times 4 is 768. So what they're actually doing is they're multiplying. They call that a ratio, a common ratio. They're multiplying by 4 each time. So to find the next number in this pattern, we would do 4 times 768, and we end up with 3,072. This is using inductive reasoning, specific examples to come up with a general conclusion that they were multiplying by 4.